Welcome to AI Paper Drop. I'm Alex.
And I'm Maya.
What if giving an AI a bigger memory actually makes it stupider?
Wait, how is that even possible? More data is usually the gold standard.
That is exactly what we thought. But it turns out that when we give models near infinite context windows, the AI stops trying to learn and instead becomes a context addict.
A context addict. I love that phrasing. But let us back up. For anyone not living in a GPU cluster, when we talk about the context window, we are basically talking about the AI's short-term memory, right?
Exactly. It is the amount of text the model can look at in one go before it starts forgetting the beginning of the conversation. For a long time, the industry race has been about making this window as huge as possible. Like, imagine going from a sticky note to a whole library.
And the logic is simple. If the AI can read your entire codebase or 10 different PDF documents at once, it should be smarter because it has more evidence to work with.
Right? But there's a hidden cost. We have been seeing this weird trend where some of these high-capacity models are surprisingly fragile. They are amazing when you give them a cheat sheet, but the second you take that cheat sheet away, they stumble on basic things they should already know.
So it is like they are performing well, but they are not actually knowing the material. They are just really good at searching.
Exactly. And this paper calls it the information abundance paradox.
Which sounds like a fancy way of saying too much of a good thing is actually bad. How does that work mechanically?
Think of it like a student in a classroom. Imagine this student has a practice test, and the teacher accidentally leaves the answer key open on the desk. Every single time the student hits a hard question, they just glance at the key.
I mean, that is just smart studying. Why would the student struggle through the math if the answer is right there?
Exactly. That is the point. The student is taking the path of least resistance. They stop trying to understand the logic of the algebra because they have learned a different skill, how to find the right page in the answer key. They are not learning math. They are learning how to search.
Oh, I see. So for the AI, the context window is the answer key. If the training data is so abundant and detailed that the answer is always just a few tokens away, the model just stops bothering to memorize the facts.
Spot on. The researchers distinguish between two types of learning. There is parametric internalization, which is when the model bakes knowledge into its permanent weights, like long-term memory. And then there is contextualization, which is just using the prompt as a scratch pad.
So if we keep expanding the window, we are basically telling the AI, hey, you do not need to remember anything. Just look it up.
Exactly. It offloads the hard work of learning to the short-term memory.
Okay, this sounds like a theory, but did they actually prove it? Like, did they see the models actually getting worse?
They did, and the results are actually wild. They found what they call an inverted U performance curve.
An inverted U. So it goes up and then it crashes?
Yes. Initially, increasing the context window helps. The model gets better at understanding long documents. But then it hits this Goldilocks zone, a peak of efficiency. Once you push the window past that point, the model's independent knowledge actually starts to decline.
Wait, so if you make the memory too big, it actually forgets things it already knew?
In terms of its ability to answer closed book questions, yes. They tested this on models like Phi 3 and Almo 3. The versions trained with massive context were statistically worse at general reasoning than the versions with smaller windows.
That is counterintuitive. You would think the model would just have the best of both worlds. It knows the facts, and it can also read long docs.
You would think, but the most shocking part is that larger models are actually more prone to this. Because they are smarter, they are actually better at finding the shortcut to avoid learning.
That is a brilliant irony. The model is so capable that it figures out how to be lazy.
Right? And they actually looked under the hood to see why this happens. They found that training with too much context shifts the gradient pressure. Basically, the model stops updating its feed-forward networks, which is where the parametric knowledge lives, and puts all its energy into the attention modules.
So, it is literally rewiring itself to be a reader instead of a knower.
Exactly. And that leads to a really dangerous side effect. When these models rely entirely on context, they become gullible. If you give them a prompt with a blatant lie in it, they're more likely to believe the lie because they have lost the internal wisdom to say, wait, that is not right.
So we are trading truth for flexibility. That feels like a bad deal.
It really is. It means a massive context window is not a neutral upgrade. It is more like a dial. On one end, you have a model that is a scholar, someone who has internalized the world. On the other end, you have a sophisticated search engine that is useless without a prompt.
So if I am building an AI app, I should not just blindly ask for the biggest window possible?
Exactly. You have to ask yourself, do I want a model that can read 1,000 pages or a model that actually understands what it is reading?
It sounds like the next frontier is not about how much data we can cram into the window, but how we force the model to keep its own internal compass.
Precisely. Because at the end of the day, an AI that only knows how to read its own cheat sheet is not actually intelligent.
It is just a very fast librarian.
Exactly. The goal is to build a knower, not just a reader.
If you are enjoying this, follow or subscribe to AI Paper Drop wherever you listen. It really helps, and we have a new episode every day.
Paper by Artie Uzunaglu, Benjamin Van Derm, Daniel Kashabi, produced by AI Paper Drop.